What if you could meet an exact copy of yourself? Someone who looks like you, shares your DNA, and is, in many ways, a duplicate. Would they think like you? Feel like you? Would they be you? This might sound like science fiction, but cloning is real, and it's changing the world in ways we never imagined. Cloning is the process of creating a genetically identical copy of an organism. Unlike identical twins who develop naturally from the same fertilized egg, cloning is done in a lab using a method called somatic cell nuclear transfer, or SCNT. The process starts with a regular body cell, called a somatic cell, from the organism to be cloned. Scientists extract the nucleus from this cell, which contains all the genetic instructions to build a life. Next, an egg cell is taken from a donor, but its nucleus is carefully removed, leaving behind an empty shell. The nucleus from the original organism is then inserted into this empty egg. With a tiny electric shock, the new cell is activated, tricked into behaving like a freshly fertilized egg. If successful, it starts dividing and growing into an embryo. That embryo is then placed into a surrogate mother, where it develops just like any naturally conceived baby. One of the most famous cloning experiments was the creation of Dolly the sheep. In 1996, scientists in Scotland successfully cloned Dolly, making her the first mammal ever cloned from an adult cell. At first glance, Dolly was just an ordinary sheep, but her DNA was an exact copy of the sheep she was cloned from. Her birth was a groundbreaking moment in science, proving that cloning was possible. But it also revealed serious challenges. Dolly aged faster than normal and suffered from health problems, sparking concerns about whether cloning was safe. But cloning isn't just about making duplicates of animals. Scientists are exploring its potential in medicine, agriculture, and even conservation. Imagine a world where damaged organs could be regrown using a patient's own cells, reducing the risk of rejection. In farming, cloning allows for animals with ideal traits, like cows that produce more milk, to be replicated, improving food production. Some researchers are even attempting to clone endangered or extinct species, raising the possibility of bringing back creatures like the woolly mammoth. But cloning is far from perfect. Many cloned embryos fail to develop, and those that do often face serious health complications. The process is expensive, time-consuming, and unpredictable, limiting how widely it can be used. Then there's the question that stirs the biggest ethical debate: human cloning. While no human has ever been cloned, scientists have cloned human cells for medical research. Some believe cloning could help couples struggling with infertility or even allow parents to clone lost loved ones. But what would that mean for individuality, for identity? Would a clone be their own person or just a copy? Because of these concerns, many countries have strict laws against human cloning, and the debate continues. There are also many misconceptions about cloning. Some people think clones appear as instant copies, the same age as the original. But clones, like any other living being, start as babies and must grow up naturally. Others assume clones will have the same memories or personality. But personality isn't just in our DNA, it's shaped by life experiences. A clone might look identical to the original, but they would still develop as their own person. So where does that leave us? Scientists are still improving cloning technology, searching for ways to make it safer and more effective. It could one day help save endangered species, revolutionize medicine, and change the way we think about life itself. But the biggest question isn't just can we clone, it's should we? What are the risks? What are the ethical concerns? And if human cloning ever becomes possible, what would it mean for the future of humanity? For now, cloning remains a powerful but controversial tool, filled with possibilities and uncertainties. Science has opened the door, but how far should we step through it?
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.